Let's see how we can use Kw in our calculations. We know that the product of the OH minus and H3O plus concentration is equal to Kw, and I didn't really mention why that was, so let's talk about that. So what we're talking about is this generic reaction. We're talking about water reacting with water to form H3O plus OH minus. Now if we write the K for that reaction, remember K is products over reactants. And what are these species here? Water is a liquid, and the hydronium is aqueous, and the hydroxide is aqueous. So remember our K is products over reactants, so that's going to be H3O plus times OH minus divided by what? Our reactants. But both of these reactants are actually a liquid, so their concentration isn't changing. So we don't consider the concentration of the water in this K. And this is a special K, so we call it Kw. And its value is 1 times 10 to minus 14. So let's calculate the hydroxide ion concentration at 25 degrees C, meaning that our Kw is 1 times 10 to minus 14, for each solution, and determine if the solution is acidic, basic, or neutral. So for A, we have our hydronium ion concentration at 7.5 times 10 to minus 5th. So we know that the hydronium plus the hydroxide ion concentration is equal to the Kw, which is equal to 1 times 10 to minus 14. 7.5 times 10 to minus 5th is our H3O plus concentration. Multiply that times the hydronium ion concentration, which we don't know. That's our variable here, and set that equal to 1 times 10 to minus 14. So if we solve for the hydroxide ion concentration, we get 1 times 10 to minus 14 divided by 7.5 times 10 to minus 5th, which is equal to 1.3 times 10 to minus 10. So our hydroxide ion concentration is lower than 1 times 10 to minus 7. Okay, hydroxide ion concentration is lower than that. That means we have an acidic solution. So we'll solve B the same way. B says our hydronium ion concentration is 1.5 times 10 to minus 9. We solve for the hydroxide ion concentration by plugging in the Kw divided by our concentration, and we get 6.7 times 10 to minus 6. Our hydroxide ion concentration is greater than 1 times 10 to minus 7, so in this case we have a basic solution. For C, we're going to plug in our hydronium ion concentration, which is 1 times 10 to minus 7, and solve for the hydroxide ion concentration. 1 times 10 to minus 14, which is our Kw, divided by 1 times 10 to minus 7 gives us 1 times 10 to minus 7. That indicates that we have a neutral solution for C.